Alright, so the question I chose was solving each equation for x. And I have three equations here, and one is 9 is equal to 5 to the power of x. Then B is 5 is equal to x to the power of 9. And C is 5 is equal to 9 to the power of x minus 1. For starters, A, and C are exponential functions because the x is in the exponent. However, C is polynomial because the exponent is greater than or equal to 2, and in this case it is greater than because it is 9. Alright, so, this is being weird. Alright, so starting with, so here are three different ones, and then starting with A, as you can see, 9 is not a perfect root of 5, so what you need to do is take a different approach by rewriting the exponential equations, where you input the base and answer and get the power instead of inputting the base and the power to get the answer. This is natural log. And the equation for natural log is ln of A, natural log of A, divided by natural log of B is equal to P. So A stands for the answer in our original equation, and B is the base in our original equation, P is power in our original equation. And it's imperative that you find the natural log of the answer first and then divide it, or because if you don't, you're not going to get the correct answer. So now let's plug it into our first equation. So it's going to be ln of 9, or natural log of 9 divided by natural log of 5. So the natural log of 9 is 2.197224577, and the natural log of 5 is 1.609437,912. So you divide the two, and it comes out with 1.365212,389. So that is the power. That's the 5 to the power of 1.365212,389 is equal to 9. So x is equal to x is equal to 1.365212,389. Moving on to part B, which is hold on, something just got really messed up here. Here we go. Which is 5 is equal to x to the power of 9. So this is somewhat different than the first one. We're gonna you have to go through a different method because you have to get x by itself. Now the equation is 5 is equal to x to the power of 9. What we have to get rid of is the power of 9 right here. So to do that, you have to ninth root it, and what you do to one side, you have to do the other. So you have to do the ninth root of 5 to the ninth root of x9, or x to the power of 9, and that so the ninth root of 5 is what is equal to x. So after that, you have to go on your calculator, find what the ninth root of 5 is, and it's equal to 1.195813174500402. So that's the ninth root of 5. So that means that 1.195813174500402 to the power of 9 is equal to 5. So your x is this right here. So moving on to part C, which the equation is 5 is equal to 9 to the power of x minus 1. So what you have to do here, again, is similar to the first one, slightly different because you have this minus 1 right here. So you have to get the x alone, and by doing that you have to subtract 1 from each side, or add 1 to each side, so that it's x alone and then plus 1 over here. And then once again you have to find the natural log of 5 and 9. So the natural log of 5 and 9 is right here and right here. And then you divide the two, and then once you divide the two, you get 0.73248676 plus 1, which is 1.73248676 is equal to x. Now you have to plug this back into your original equation up here. So 5 is equal to 9 to the power of 1.73248676 minus 1, which is pretty much just this right here. And that brings you to 5 is equal to 9 to the power of 0.732986676, which is 9 to this power is equal to 5. So moving on to my real world connection here, and In the real world, natural logs, which is what we use most of the time, are observable in carbon dating. And what you use carbon dating for is when you find fossils of different animals. Like right here, we have a bunch of different dinosaurs, and when you find fossils for those dinosaurs, you'd have to use carbon dating and natural log to find how old they are exactly. So I hope this video has helped you with all your natural log problems. Patrick signing off.